Hello everyone, today I'm going to explain about peer-to-peer carpooling, and here in this concept about peer-to-peer carpooling we are going to use smart contracts, and then we are going to solve these carpooling issues one by one. And in this PPT I'm going to explain you what is carpooling and how we are going to implement it and why do we need carpooling in the first place. So actually, carpooling is nothing but whenever when we own a car and we are going to the destination, which we're going to same destination, and also our community members or our friends also want to travel the same destination. So what do? We just make a phone call to them, or else they come to our home and we go through them. But what if a person is stranger and we don't know where he's going to travel? So here comes our app and it deals with this kind of issues. And one more thing, whenever these kind of issues raise, Uber, Ola is always there for us to help. But in this situation, our data is not private and is not hidden. This data directly go to their servers, and these MNCs can manipulate our data so easily and so conveniently, and can even sell our data to other MNCs in the worst case. So in order to save that and in order to avoid that, we are trying to implement this app through blockchain system where the data will be privately hidden, and we are gonna make this on XDC network, and we'll make it a D app, which is digital app or decentralized app using smart contracts concept. So let's see what is our agenda. So once again I wanna tell that what is peer-to-peer carpooling. Carpooling, also known as car sharing or ride sharing and lift sharing, is the sharing of car journeys so that more than one person travels in a car and prevents the need for others to have to drive to a location themselves. And why do we need peer-to-peer carpooling? Well, there is a immediate need for that. It usually means to divide the travel expenses and equally between all the occupants of the vehicle, driver or the passenger. Driver doesn't try to earn money but to share with several people the cost of a trip he or she would do anyway. The expense to be divided basically include the fuel and possible tolls. In this carpooling, actually what we are gonna do is the amount will be shared with every one of the person who is sitting in the car and every each and individual. This will be a benefit and a win-win situation for everyone, as the cost of maintaining a car will be reduced for the owner. Implementation of this model in Solidity using smart contracts. Here we will see that how we are gonna implement this model using Solidity language, which is based on object-oriented programming, and making a D app through XTC network. Let us see about peer-to-peer carpooling further. Peer-to-peer coupling system in which we can connect to the driver directly without any third-party applications with the use of blockchain technology. First of all, why do we need peer-to-peer carpooling? As I have told you earlier, but I want to tell you once again in a very detailed manner. Third-party agencies like Uber and Ola have all the data of drivers as well as of riders, and this can lead to major privacy issues. And company can use this data for its own benefit, or it can even sell the data to other companies. Data of user is kept private, secure, and encrypted. Which avoids data breach. Trust to drivers. With the help of peer-to-peer carpooling technology, the drivers can trust the riders that they are real users, and the information shown is verified through blockchain technology. And this flowchart, which is going to help us a lot in understanding what carpooling actually means and how carpooling is gonna work. Let me just explain you briefly. First of all, you need to what do you call, you need to register to our app with your ID, insurance and everything, and you can just sign up to our app very simply. And after subscribing a service, you can just see all kinds of service whatever you want to select in our carpooling system. Here there are carpooling, managed services and booking carpooling, and this will ask a subscription further. and this will carpooling factory will fetch us about safety, service, and much more. This will enhance our carpooling system in a very efficient manner. Coming to the revenue part includes about the passenger, how much passenger wants to pay in a carpool. The rate will be set by distance and the hike of petrol prices. So we are going to build this model as DApp, digital app of a decentralized app using solidity language through smart contracts concept on the XTC network. I will explain you about this, about GitHub link and the code further.
So hello all, we are going to discuss our model peer-to-peer carpooling. So these are the files. So now we discuss how to book a car. We can how to create a carpooling system. We can discuss factory for carpooling and managing the carpooling. Then we can discuss about meta variables. Now let's discuss about one by one briefly. Now this is a function called as booking car. So here we are making a function make booking, which is used to add seats to the passenger, and we are checking these conditions. And this is the function called settle booking. It is used to make a booking, and it checks whether the carpool is valid or not. And this is the function ask refund booking. It is used to ask or remove in slots, book and for refunds. And so this is the function validate refund booking. It is used to validate the refunds, and it has rights of only owner should access. So this is the function add in available slots, so that it checks whether the slot is available. If it is available, it can book. Else it can't book. So let's go to the next one. So now we are discussing about the carpooling abstract. So now we are creating a contract carpooling factory as app. Now we are explaining creating function set for pending service carpooling user option, which is used for check whether the carpool has successfully verified. Next, finally, we have to approve the amount. Now this is a modifier like name only carpooling members. It is used to check whether the address is only the carpooling members or someone else. So here is a function withdraw refund. Here it is accepting the address of the. If it accepts this service, it has to give the amount. So this is the calculation. The amount for the driver. It's function balance of each to the balance. So it is the button is public. This number of book decreases state and get the slots of refund. So these are the three features I use to start the car booking. Creating a contract and importing dot meta variable as solid. Here we are creating a contract. Now we are creating a modifier owner only, and we are checking whether the user is a owner. If it is, we are going to the other parts of the code. So we are creating a constructor here. So we are assigning those values to the data members. So this is a factor of carpooling. So we are creating events, and now we are getting a function called as create carpooling link to the factor contact. So this is how to get a carpooling address by using this function get carpooling address using index. and this check whether the function says join safe registry or not. And this is function set the service registry or to get the service registry. And these are functions set pending service carpooling user option. If you use status user, set service carpooling user option. And this the service can validate the user query. So move on to today. So we are creating a contract and managing carpooling. A function called as validate booking. Now we are checking whether the passenger has the services required or not. If yes, we have to validate the carpooling trip. Yes, we have to. Now we are creating a function validate refund. We are checking whether the owner has to validate a refund who has cancelled any slots. Now we are creating a function carpooling which has only admin rights. If it's admin means we are calling the function refund some users. We are creating a function solve conflict which is used when there is a crash in the app. This function refunds some users. This is used to create a refund to most of users. This is used to find whether the refund find one user, whether it has one or many users. And this is meta variables. We are creating a meta variables called interface meta variables, and we are creating a list of states and a list of mode conflicts.